I would like to start by putting this very important milestone in a broader perspective. In simple terms, there are three essential components to a particle physics experiment: the accelerator, the detectors, and the computing. Israel, Japan, Russia, and the United States. Indeed, some 80 nations are represented at CERN, and we estimate that over 10,000 scientists and engineers from around 500 academic institutes and industrial companies worldwide have contributed to the construction of the LHC and its four large detectors: ALICE, ATLAS, CMS, and LHCb. At the collision point, energy is turned into mass, according to Einstein's famous formula E = mc squared. Occasionally, this leads to new particles being produced that are not stable in our universe today. These particles decay in a fraction of a second into other, more common particles which fly off through the detector, and it is this decay product that the detector registers electronically. The computing turns a huge flow of digital data coming out of the detectors into useful physical information about the collisions and stores that information, which is processed in a search of those rare events which are new particles, where new particles are produced. This is a function of the worldwide LHC computing grid. It stretches around the globe, connecting resources in hundreds of data centers in over 30 countries to form an unprecedented computational and storage device. At the end of the day, the net product of this huge enterprise is pure knowledge.
It depends on what, how kind nature is to us.
But we suspect there are physics which are beyond what we know today. I declare formally that the worldwide LHC computing grid operational, fully operational. The first time I see the grid, something as solid as that.
He was doing it, he achieved it, and I still don't know how he did it, but we have every reason today to celebrate the success and congratulate Les in particular.
Maybe Jos didn't notice how he did it because it wasn't too difficult. So I really like to thank everybody. Some people are here. Many people are not here today. People from physicists, engineers, computing people, people who have nothing else to do with hydrogen physics, but who are computer scientists who participated in the GRID projects. All the funding agencies who've helped us. So I'd like to thank everybody for this.
Can you hear me in Amsterdam?
Yeah, I hear you.
Okay, so in Amsterdam we have a joint institute, the institutes of Nick F. and Sarah.
And I think this is a moment to give a very big thank to these companies who have supported us for so many years. In order to formalize that, we have a little gift to do to the companies, and we have just to get it behind from the curtain. Thank you very much to the companies, first of all. Ongoing collaboration, and I hope it will continue for a long time. Thank you again.
Thank you very much.
Is the one we are considering, where
Là, on prend des données à presque 100 Hz.
I've been working here since 1974, always on physics computing services, starting in the days of supercomputers. Then we had mainframes, then we had another supercomputer, and then we started moving in about 1989-90, we started moving into small clusters of microprocessors. So there was a big issue in convincing people that this is something that we should invest a little in. I mean, the amount we had to invest, of course, was very small compared to what we were paying for the big computers, which we were still using in the center. But within about 18 months, we had more capacity. We were delivering more capacity from these little systems than the big computers in the center.
If you think about the way the data comes from the experiment, it comes directly to CERN, to the tier 0 where it's stored, and then it's distributed out to 11 tier 1 centers. So these are major computer centers distributed around the world, and they have a responsibility for storing a second copy of the data, so they have to be reliable. And then we have a set of something like 130 so-called tier 2 sites, which are typically university departments, other labs around the world. And this is really where the physicists get hold of the data. So you can think of the data flowing out from the tier 0 to the tier 1s to the tier 2s. And as it goes out, more and more people get to see it and get hold of it.